Alrighty, we're gonna start this video again. This is the beginner section of the real number system. First thing we're gonna do is label all of our boxes when we put a Venn diagram or a chart together. This is the real number system, so of course they're gonna be up at the top. The two brothers are irrational and rational. And irrational, we know, is the pi family, and it's gonna stay all by itself over here by on the right. And then rational numbers has three little friends underneath it. We're going to start at the bottom this time with natural numbers. Those are the counting numbers, the very first numbers you learn, 1, 2, 3, 4, etc. Then come the whole numbers when we teach you about 0, 0, 1, 2, 3, 4, and so on. Then come integers, which are the negative and positive whole numbers, which includes 0. It's like a perfect number line. Rational numbers have all the fractions involved, and irrational numbers are like pi. They just go on and on forever. The next thing we're going to do is identify each natural number from this list, and we're going to do that by using our calculator. We're also going to separate them just by drawing lines so we can easily tell the difference of what's going on. So if we use our calculator for 18 divided by 2, that gives us 9. That definitely looks like a counting number. Then we've got a 0 that goes there. If we want to know what 3 1/3 is, we're going to have to put that in your calculator so that way we know what it looks like. So if you put in 3 and then you put 1 divided by 3 next to it, hit enter, and then click on your answer button, it actually gives you the decimal form, which is a repeating decimal. So that is definitely not going to be, let me get this to right for us again. That's definitely not going to be what we need to use as a natural number. So that's 3.3 repeating, negative 13. 6 is the 6.0 is the same as 6. And then we're going to come over here and we're going to put in 2 divided by 7. So 2 divided by 7 is a number that just seems to go on and on and on forever. I'll write a few of the numbers and then I'm just going to put dots. So natural numbers are your counting numbers, 1, 2, 3, and so on. So right away that decimal is out and that decimal's out. Negative 13 is out because natural numbers do not have negatives and they do not include 0. So that means your two natural numbers are 9 and 6. The next problem asks to identify each natural number from this list. So again, we're going to talk about natural. It's the very first counting numbers you ever learned. So a negative is going to go away right away. Square root of 81, if you put that in your calculator, is 9. So that is a natural number. Number 1 is definitely a natural number. Then we're going to come over here, use our calculator to figure out if 57 divided by 3 is 19. That is also a natural number. Then we're going to use our calculator to check 1 divided by 3. That's a repeating decimal. So if it is a decimal, that means we're getting rid of it. Okay. And then finally, we've got 12 divided by 8. So let's go ahead and put that in our calculator. And that gives you 1.5. Again, that's a decimal, so we will not be using that. So on this question, we had 3 numbers that were natural. This next one is asking us to sort the numbers by whether they are rational or irrational. So we're going to have to use our calculator a lot here. First thing we're going to do is negative square root of 87. That number is negative and it goes on forever. 3, 2, 7, 3, 7, 9, 0. No pattern at all. So that means negative square root of 87 is irrational. The next one, the 1, 3 is repeating. If you have a repeating decimal, that makes it rational. So we've taken care of that one too. The next one is a terminating decimal. It stops. 0.21953 which again makes it rational. So I'm going to put it down right there. The next one we're going to look at is the square root of 12. So the square root of 12 gives us a number that goes on and on forever with no pattern. So again, it's irrational. Pi is the poster child for irrational numbers. So we know where that goes to. 0 is definitely rational because it is a whole number. And then we have -4 and 2/3. So -4, and then we're going to space, and we're going to put in 2 divided by 3. And we're going to see what that gives us. We're going to go to the next line, and we're going to click answer. It gives us a repeating decimal, which would make it rational. So -4 and 2/3 goes under rational. Irrational is a decimal that goes on forever without repeating and without any type of pattern and without stopping. So the next problem we have here is the number 3.7 is best described as what? A rational number? Definitely not an integer, because an integer is number lines. A whole number, 0, 1, 2, 3, so that can't be it because there are no decimals in a whole number. So we've already gotten rid of those two. And it is definitely not irrational because it stops. So the answer is a rational number. So we'll go on to the next one. Which of these is a rational number? Well, first of all, let's look at the square root of 2 and see what happens there. Nope, definitely irrational. So that's not it. The next one is 0.414114. So that is also irrational because the pattern is not consistent. So let's try the square root of 5. And it does not have a repetition either. So let's finally go down to D and see that the 0.6 is repeating. So that would make it rational. So D is your answer there. Let's go on to the next one. It's going to be the real number system intermediate, and that'll be on your next